Hey guys, so I'm seeing Dr. Z's is going to raid this stream, so I guess I should start soon. Let's kill the music a little bit. The man, the myth I'm hearing, well, let's hope so. We're going to try and solder something again today, and who knows if it's going to work or not. Okay, closing the Dr. Z stream, this is confusing. Anyway, welcome to the pre-stream, I guess, because we're 10 minutes early, but we do that more often, so hey. And yeah, what are you guys up to this weekend? Party time! Oh yeah, evening all, raid, nice. Thanks, Dr. Z's. Oh, my camera moved slightly. This cable is just not long enough. There we go. Nope, too much. There we go. So, what are we doing all this weekend? I was going to show you my Coke, but I forgot to get it. Well, we're still in the pre-stream, so I'm just going to get it. Hold on just a second. Oh no, I have to have my drink. Okay, I'm back. Don't worry. There we go. So, seemingly they've renewed the Coke cans, so now we're having Coke Zero, but this is, no calories, okay. Oh, this is cherry, but normally they just have the black can with the bar on top, but they have new cans, it seems. And this is the regular one. I guess it's more in line now, so that's good. And I don't have the vanilla one. I guess something went wrong with shopping those, but we'll see. We'll live. You are rated by Dr. Z's! Yes! Before we start, this must be important. I have a question. What do you think about Govi LED strips with voice control support? I have no opinion on those. Generally, they use WS2811, so I actually have one lying here that we're going to use later on. They're pricey for what you get, but it does work. It's not bad stuff. I don't know. I like using my own boards and WLED and having fuses and stuff like that. Yeah, so I've never used it, so weird color. Yeah, the cherry, I guess so. Those cans are small. Yeah, well, they're normal can size. 250 milliliters. I do not know what that is in freedom units. Yeah, don't know. Hit that like button. Oh yeah. Close enough to pink for you. Nice. Yeah, Johnny, is it? US cans are 2-liter bottles. Yeah, that's a bit much. Yeah. Will the previous Dig-Uno board accept an ESP32? Absolutely. No problems there. Check the pinout guides and it shows you which pins it are on the ESP8266 and on the ESP32. 355 milliliter are cans. Yeah, we also have the shorter cans, but they're fatter. I think those are also 330 or something like that. Yeah, like Micah was saying. What about our 5-liter Coke bottles? What? How do you handle that? It's like a jug, a jug of Coke. Big gulps. Yeah, we don't get those. Or maybe we do nowadays, I don't know. I want to use them on my QuinLED controller. Well, if they're compatible, they're compatible. I don't know how to say that. If it's a compatible chip that the LED uses, that should be fine. As I said, I believe Govi has WS2811s, so yeah. I need to check the mix of my music and my audio because it was a bit loud before. Should be good now. Any plans on designing an I2C extender PWM board for bigger installs? Would be nice addition to the analog lineup. I do have plans there, but I have some more digital LED plans first. We just finished the AN Penta for analog LEDs. I have lots of plans, but you know, time is a thing. So yeah, maybe in the future, but right now, not so much. I had to say hi for Johnny, who was supposed to not be here tonight. Hey Johnny, what? He came anyway? I don't see him. Oh, there he is. Nice. There's some pink in the LEDs behind me. Oh yeah, I've shared some of the plans with Dr. Z's. Okay. Well, we're kind of the partners in this, so gotta show him the stuff that's coming. Evil plans, not evil, just awesome plans. He's a fake sweet. What? Oh, now I got my Coke and I'm forgetting to drink it. I still have 2 minutes of airtime I need to fill before we get to the subject. You were waiting for RGB controller? I think all of the controllers I've ever made, except the QuinLED OG, can do RGB, so... Oh, Mr. SEKS is here. The embedded hobbyist is here too. Pepsi Max. Ah, no, I'm a Coke Zero guy. I heard a rumor of a dig with microsd. Yes, that is somewhat of a rumor. But if you look here, and maybe there's a microsd card sticking out here, and is there? Yeah. And look, there's a QuinLED ESP32. So that's not a rumor. That's actually something I'm working on, and that will come out at some point. Actually, it'll come out sooner than later, and it'll have some nice goodies like a touch button and a microphone and an IR receiver and an SD card slot and extra LED channels, and that is not so much a secret anymore since I showed it. So yeah, that is certainly coming. Absolutely. But there's more stuff coming. There's always more stuff coming. Have to have more stuff coming. 150 milliliter cans of Coke, those are small. Why SD card? Well, it's kind of an alternative to the Ethernet version, because with the SD card version, you can then, if you're doing Christmas light shows with X lights and stuff like that, you can put the sequence files on the SD card and just do the timing over Wi-Fi instead of streaming all the LED data over Wi-Fi, or, well, then you use Ethernet. So it's kind of an alternative to that. And yeah, it will be a little hat. Okay, I'll show it. I'll show it in more detail. Normally we do the secrets at the end of the show, not at the beginning. But you know how things are. So let me focus that. There we go. It's a bit bright, but it's okay. So this is the QuinLED ESP32 ABE. That has the Ethernet board on top, and this will be the AE Plus, which has touch, infrared, microphone, SD, and 3 extra output channels. Now, I already have made a new prototype of this one. I haven't built it yet, but I'm hoping that's going to be the one. And as you can see here, it has a micro SD card slot, and then it has an IR receiver here. Touch button here, and it has a microphone here. It's a digital microphone, so that's automatically all connected to the ESP32, and then it has 3 extra digital LED output channels with level shifters and resistors and stuff like that. And then if you take a Dig-Uno, this is a Dig-Uno, hold on, for instance, or a Dig-Quad, it will fit on both. You can just take the old one off, put the new one on. There we go. And the SD card even clears the fuse. Hey, design there. And yeah, then you can use it on your existing QuinLED controllers. You have to have the most recent versions, but that's the one we've been selling in 2021. Yeah, and it'll work on a Dig-Uno or a Dig-Quad. Yeah, it's not a secret anymore, so I guess I can show it at the beginning of the stream. So anyway, today isn't about any pre-assembled stuff. Today is about DIY stuff. Because, well, that was a pre-assembled QuinLED-Dig-Uno, but I've been working on new versions of the... wait, it's just too bright. It's too bright. Maybe if I zoom in more. There we go. No, now it's not bright enough. Jeez. There we go. So this is a new revision of the DIY version, because that had been stuck on V2 for the Dig-Uno for a while, and I've recently found some time to basically revamp that to get in line with the pre-assembled version. Some features do port over, some don't, but yeah, we're going to build one today. And this is the latest prototype of the DIY. It says it right here, DIY. Can you load the SD card over Wi-Fi? Yeah, sure. No problem. I've been testing it with ESP PixelStick V4 beta firmware, and there you can just upload your files using the web interface, and then FPP can start them and time them and stuff like that. So that's a really cool feature. There's a secret handprint on the cork. No, there's just burn marks. Oh, of a ghost. Okay. Anyway, I think it's time. I think I'm just going to start building it. We're going to be using this kind of stuff again. Let me lower this a little bit, I guess. Oh, no. Yeah, there we go. So this is an interactive BOM, so an interactive bill of materials, where we can easily highlight like, okay, I need an 0805 10 volt 0.1 UF cap, and then it highlights, let me go there, down here, which components those are, and once we've placed those, it'll highlight them green to let you know we've got them, and then, you know, we put these there, and we do these, and so it makes it really easy to figure out where to place everything and stuff like that. I used to do that in guides, but since this is available, it's a much better way to do it. So I think we're just going to go start building it. All the documentation on QuinLED.info is still of the current variant, because this is literally the first prototype I'm building of this version of the board. But once that's good, probably some changes will emerge, like, okay, I want to use a different size capacitor here, or during stress testing I identify something I want to change or something like that, or it doesn't work at all. Who knows? But yeah, we'll see, and after that I'll release the new files so you can order them at PCBWay and Dirty PCBs, and you know, have the interactive BOM, and I'll probably do a soldering video, or maybe I'll use this live stream for that, and stuff like that. I've been begging WLED and ESP PixelStick for physical DMX in support. It's the last thing I need. Can't help you there. My boards don't do that either, so... Love the DIY boards. Cool. Well, this will be updates to that. So, I'm not sure how to do this. Let's go to this camera. And I guess I could keep this somewhere over here. And let's see if I can add my Chrome view. Okay. You see, that's way too small. Is it too small? I don't know. If I leave it like that in the corner, can you even see what's going on? Oh yeah, Philip has a lot of parts. I saw the question about kits earlier. Yeah, so I usually put links to AliExpress because you can get all the components the cheapest there. And if I'd had to pay someone to gather all the components, baggy them up, label them, and then you know, put it in a package, maybe include some instructions, and then ship them to you, you'd basically be talking the same price as the pre-assembled version already. So yeah, it makes it kind of difficult to do the DIY in a kit version. So that's why I think, like, okay, if you want to do DIY it, so you get to order all the parts and wherever you want, you can order them on AliExpress or somewhere else. And yeah, so that's kind of my stance on that. But we do have an experiment going with Philip, who will be making kits available at some point just to see how it goes. But yeah. Native support of the temp center by WLED would be nice. Yeah, it's a compile away, and I believe it's working correctly now, but I haven't looked into it yet myself, so. I'm in potato vision as always. Okay, looks just fine. Okay, good enough for me. Nice. Okay. Then let me go there. So I have my my little 3D printed boxes here, and these are components I use more often. Oh, dang. And they're on little clip-in modules, so I can just take these out and then get the components and then clip them back. And right now, the first component we need is a 100 nanofarad or 0.1 microfarad capacitor. And well, that's in my box here. But for some reason it's sliding a lot. I cut it too small. There we go. Okay, and we need, how many do we need? 2. Okay, we need 2. That's fine. So I get 2. I will try and chat at the same time, but sometimes that's difficult. Okay, I just put them on my little toaster mat here. In Dutch we call these an onderzetter. They are for pans and such. So let me orient the board the same as we're seeing there. Yes, okay. And we're using the same only for professional use solder here. But it's just leaded solder. It's still easier to work with leaded solder, and these aren't going to be solder or something like that. So I am going to turn on my my suction device. So that is going to make some noise. Let me know in the comments if that's okay or not. And I'm even going to put on my splash guard, as I call it. It's not very nice with headphones, but okay. If anyone's wondering what kind of soldering unit I'm using, I'm still using the T3A that I showed off in a Quinbox recently. It's also on the QuinLED equipment page, and that allows me to use various tips and stuff like that. But the most important thing, it heats up like crazy, so that makes soldering very easy. I'm also going to be using my titanium tweezers. I've been using these for I don't know how long now, and look at that tip. That tip is still perfect. So I really like those. Onderzetzer. Yeah, that's pretty similar. Yeah, so the old boards already permitted the use of my ESP32 boards, but the new boards will also permit the use of things like Ethernet or that new shield I just showed and stuff like that. So yeah, absolutely, because this will have the exact same pinout as the pre-assembled got earlier. Oh, thanks for the link, Philip. So, we need to... Oh no, I put it on the wrong component again. I need to watch out with that because I used the mouse. So we need one down here. So what I'm going to do, it's the left pad. I'm just going to tin that pad real quick. There we go. And then I'm going to take my tweezers. I have to turn this sometimes. I'll try and keep it in shot, because then I take my little component and then I melt that tin pad, and then I put the component on there, and that's it. And now I should be able to melt this pad too. And then for good measure I always touch it again. And there we have our first component soldered. Oh. Okay, so we'll do the same here. And I'm using a way too big tip, but once you get used to soldering, it doesn't matter too much. Okay, second component. Yeah, so, okay, I need to change the orientation for this, sorry. There we go, much better. Okay, so now we can tick those off. Done. The 10 volt 10 UFs should have those here too. Yep. So I just take my little 3D printed thingy here. I move out two, and then I just get them out and I put it back. It's only useful if you do it a lot, and I use these components a lot. So let's do that again. Tin the pad. Get the component. Do the other side. Okay, this tip is just slightly too big, but I'll manage. I don't feel like changing it out, although it's easy to... Okay, I'll change it out. Never mind. I forget how easy it is with the new soldering iron to change the tips. There we go, we have a new tip. 1 second, and it's 350 degrees. Okay, there is a second one there. Let's see which one it is. Oh, it says cap 10 UF over here. There we go. Oh no, I moved it. Okay, that should be fine. I think. Let me check. Okay. Maybe I need to touch this one real quick. There we go. Okay. Yeah, that should be fine. That should be fine. Okay, done. Ah, okay, so here is an experimental one that says 1206 10 volt 100 UF, and you can certainly use that, but I kind of just put it there to have a decoupling cap after the voltage regulator or the DC-DC converter, and I wasn't sure yet, but I think I'm just going to go with a 10 UF 35 volt. So I might change that silk screen at some point, and I also might change the size, because if we just use a 10 there, it's going to be the same size as the other 10s. So that is one less component you need to buy. Okay. There we go. No more granny cheater glasses for me. Yeah, I do okay with... maybe I can zoom this in more. Yeah, I can actually. I do okay if it's 0805 or 1206. 0603 is doable. 0402 I get the magnifying glasses and the microscope out. That's for sure. Okay, so those are done. I guess that's all the capacitors we need right now. Oh yeah, Philip, that's absolutely right. I mean, I'm not a professional solderer. I'm just some guy doing this too. You know, who likes to design hardware. And okay, so we need... Oh, well, actually, we don't need 4 10Ks because these are these pads over here. So this one, this one, this one, and this one. And those are the pull-up resistors for Q1 to Q4. Now I am wondering where the one for the button has gone. That should also be a 10K. But it's not. What value did I use for the button? Ah, it's also a 10K, but it's named button. Okay, so I am going to do that one. So I'm going to skip these because I'm not going to be using Q1 to Q4, or at least I don't want a hardware pull down or pull up on those. So we're not going to do those. But we are going to do the button here, because that needs a 10K, and I just have those. Okay. No. This is a 10 UF. I don't need capacitors right now. I need resistors. Okay. And if that button thing doesn't make sense to you, I'll explain that in an accompanying article. Don't worry about that. But it's basically the Q1 to Q4 are extra GPIOs you can use, and sometimes you want a hardware pull-up on those or pull down, and sometimes you don't. So that's why I'm not placing them right now, because I don't have any plans for it right now. And if I do, I can always place them later. So we place this 0805 resistor. There we go. Solder the other side. There we go. The ink screen chat. Is it? What? No, it's not. It's not under the. It's under the window frame. No, it's not. At least not in my OBS. Pink smoke. What? USB-C hardware design is giving me a headache, or is it the alcohol? Yeah, you never know. You never know. Okay, so we did that one. Now here is an interesting one. It's about these two resistors over here. And if you all saw my resistor articles, I specify to use a 249 ohm resistor there. But that is mostly for using LED strips and if you have a single data line without ground running right next to it. If you do have a 3-wire cable instead of a 2-wire cable, you should use a 33 ohm resistor there. So then you can use, then it's optimized for 3-wire cable, but not a separate data connection. But since you're building a DIY, you can just put any resistor there you want. In my case, I am going to be using, what am I going to be using? Because I don't have a 249 or 33 here. Interesting. I'll get it out of one of my books. Hold on. Wait! Donation! Let's show that. Okay. Will there be pink LEDs? Also, SAKS rules. Sure, Johnny. Maybe later when the LEDs are working, I can make some pink for you. And there's already pink LEDs in my background. Oh, this is 0402. No, I don't need 0402. This is also 0402. Uh-oh. What's this? This is too small. 0603. I should have an 0805 booklet. Oh, there we go. Okay, so I have some of these books which have lots of pages of different resistors and stuff like that. And, well, in this case, we're going to use a... oh, we don't have 249. So let's go with 200. That's close enough. Let me get one out. But yeah, you can read my resistor article, and then you can optimize the board you're building for the scenario you're going to use it for. Because it's DIY, you can choose anything you want. So that makes it very easy. Okay, let me tin some pads. There we go, nice little balls on there. Now that's not the neatest soldering out there, but it does make it easy to use. Let's get the resistors. Come on. Now, are we OCD enough that they need to be the right way around? Uh-oh. I'm actually not, so that's probably going to be triggering some people. That's one. And that's two. At 3 tombstone style, yeah, no. Okay, let's do the other side real quick. I don't like this tip. I need to get a different tip. I thought I'd like it, but I don't. Anyway, that's fine. So we did the resistors now. 4.7K, that I have over here. That is for the temperature sensor. Not sure we'll be soldering that today, but it's fine. Let me move this one out of the way. That's down here, I know from head. Wait, not? It's not? Oh! We're using it for the LED, and then we have another one. Okay, I need to see, that's why this is a prototype. I need to work on the BOM file, because now there's 2 types of 10K in there, and there's 2 types of 4.7K in there, while they are actually the same. But then I named it slightly different, so it shows up as 2 different items, while they're actually the same. So yeah, one goes down here. There we go. Now I often get comments from people who feel that soldering SMD is so hard. I just don't get it. Maybe it's just because I don't have bad eyesight that I just don't know how to relate or something, but I find it so easy. Because you just tin a pad, put the component there, do the other side, done. Okay, so now all these are done. Okay, we're at the diode territory. So then I'm gonna switch back to my my heavy gauge tip here. Okay, so then I can do the diodes more easily. Now let me get 2 diodes out of my box that is named diode. Okay, let's SS24s. I have a bunch of those. Okay. And those diodes you always have to watch out for. They have a little stripe on them. You should be able to see on this one, I think. There, this side has the stripe, and the board also has those stripes. So you need to make sure that those basically line up. Like that. Or well, you know. So we're going to do these the same way. By the way, the event thing in Discord is visible now. Very visible now, if you have time to check it. I'll try that in a minute. So let me do these diodes first. So I'm going to use my giant soldering tip here, and I'm just going to melt some solder onto this pad. There we go. Melt that into there, make it a little bit neater. And then we do the other side. There we go. That's one diode. Now let's do this one. Make sure it's the right way around first. We tin the pad. Oh. There we go. That should be fine. And there we go. Diode's done. Could be prettier, but that'll do fine. Okay, so Philip told me to check Discord real quick. Let me do that. Because the event should be visible now. Oh, it actually has a calendar thingy. Wow, okay. Happening now. Event details. That's cool. Cool. That's cool. That's cool. Nice. I'll be using that more often. Thanks, Andy and Philip. Andy and Philip are my Discord admins. They do a lot of the stuff I don't have time for often, so it's greatly appreciated. Let's see here. Oh, we need a PTC for extra protection, and then we're done soldering things on the back. Do I have a box of PTCs here? No, actually. Oh, I do. Let's see here. This one should be good. 1206, yep. There we go. And, well, we do the same treatment for that as all the other stuff. We tin a pad and then place it. PTCs like caps and or resistors do not have a polarity. Oh, it's sticking up a little bit of solder. And it's not straight on the board. Let me see if I can do that better. No. What have I done? Okay, let that cool down for a little bit, and then I'll touch both sides, and then it should be all pretty again. I could also use some flux, but generally adding some solder also has some flux, so that should work. Okay. There, that's prettier already. And then this side. That should be fine, I think. Let me check if that's soldered correctly. Yeah, I think it's good. I think it's some of the solder is just under the pad. That's fine. Okay, so we're done with the bottom part. So we're going to the front part. And over here, we're starting... Let's see. I want to start with the SMD components on the front first. But there's only a single one, and that's an LED. Is my orientation correct? No, I haven't turned it around yet. Yes, it is. So we have a spot for an LED here. Let me get my box of LEDs. In this case, it's a 1206. I debated around making it a 1206 or an 0805. Let's do an orange one. I don't know. Oh, do I have a pink one for Johnny? No, not in that size. Sorry, Johnny. Okay. Life is an STD. It just takes longer to kill you. Well, that sucks. I always forget. Oh, there's a little dot here, and I believe the dot is ground. So there should be a little arrow on the LED. And, well, this isn't really an arrow, but still it's pointing that way. Normally that means that way is ground. So in this case, I believe it should be like this. But we'll find out when we turn it on. If it's not like that, generally the LED is fine, everything's fine. You just correct it and then it's fine. So now the components on the back makes this a little bit harder. There we go. Okay. And there we go. That should do. And I believe that's it for all the SMD components. So we can put the tweezers and stuff like that away. Yeah. So now let's do the capacitor last because that's highest in height. What I usually do is I solder going from the least high component to the most high component. So in this case, I believe the level shifters, the level shifter would be the least height. So let's get a level shifter. Oh, okay. Let's get one of these. I believe these are. Is this AHCT? Yes. Okay, they're in a little container thingy because I got them from AliExpress. Get the tape off. Okay. Wow, there's 115 people watching. That's a lot. Oh, okay. I was going to say I need to put the notch on here, but the notch is on here, as you can see, next to this USB here letters. So it should go on like that. And often with these you need to bend the legs a little bit so I get a hard surface, and I bend them inward slightly. You can also use a socket if you want to. I generally don't for these, but there we go. Let's try and get that in. Okay. That is in. The notch is on the right side, and this is the HACT version. You can use the non-HACT version, but then it's less suited for some other types of strip. But for WS2812B or SK6812, it should be fine still. But yeah, I'm just going to use my big tip because, I don't know, I like using that. Have to wait for it to heat up. just a few seconds, and there we go. Yeah, if this looks way too easy, again, check out the equipment page for the T3A soldering iron. That thing is just a beast. Especially with this big tip on there. It doesn't matter if it's like fully connected, not even thermally relieved to a ground plane or whatever. It just solders like an idiot. Okay. That is a level shifter on there in the correct orientation. Let's skip this. Let's see, what else do we need to do? I think the next one in height is the fuse socket. So let me get one of those. Because I believe the terminals are higher than the fuse socket. Now these can be a little bit of a tight fit. Oh, there we go. That's okay. That should be fine. What temp setting on the solder tip? 350 degrees. Why is unexpected maker mooing? That's a shifty looking shifter. Didn't you recover that from some 90s tech? Who knows? They've been around for a while. So, could be. Let's see if we can get this soldered while it's moving around. Okay, that's fine. Okay. Now, these are connected together, making a bridge. But since they're connected together anyway, I could remove that easily, but it's fine actually. So let's do this one. And this one. And this one's going to be a bridge again too. That's fine. Yeah. The day I got a Weller station, I was so angry, wasted so many years with cheap irons, right? Getting a decent iron is, if you do this more often, or even just for fun, I think it's worth the money. It's just, especially with these changeable tips too, it just makes it so much better. And it heats up in seconds, so that's amazing. So yeah, these are bridged, but that's fine because they're the same net, so that's not going to make any difference. Okay, so now we have a fuse holder. Let's see what we do next. Either the pin headers or the screw terminals, and I don't actually know. So let me figure that out. I once wrote this in a guide somewhere, but that guide's been a few years ago. So let me get some screw terminals. I generally like to use black and red for these. So these are blue and black. So this is the screw terminals. Good, still all fits. Because remember, this is a prototype. I'm not exactly 100% sure everything will still fit. And let me get some pin headers. Where are my pin headers? There they are. I'm just going to get a row. I have a bag of pin headers, so I have a box of pin headers. Okay. unless you do the headers with the ESP attached, it's the screw terminals first and then the header pin later. Yeah, but I like doing the ESP headers with the ESP attached, because then I know the spacing is correct immediately. So let's see, because yeah, see, these are lower than the screw terminals, so let's do screw terminals later, and let's do the outer pin headers, because there's some here and there's some here and here. So let's I mostly just look at it and then snip it off. So these would go over here. Oh. And then I need a set of 2. And then over here I need and another set of 2. There we go. And then over there I need 2 of 2, because that's easier to solder. So we do it like that. Nope. Like that. Yeah. Come on. Okay, let's do those the other way around. Why are these going in so difficult? Did I not use the correct hole sizes? Oh, I did. Okay, so those should be all male headers, and I'll do the female headers later. But what I'm going to do is I'm going to take my board, I'm going to take my cork and put it on top of there, and then like this I turn it around, and then of each of those individual parts I solder one of the pins. There we go. Because we'll check for alignment after that. So I know these are... Oh, no, get the solder onto the pad. There we go. I know these are separate. Oh no! What did I do? Get back over there. Did it again. Okay. Well, that's fine. So now we should be able to turn the board around without it falling out. And we can check how straight they are. And, oh, these could be straighter. So we can either bend them a little bit, if it's a little bit. There we go. Or we can, while holding it, touch the solder on the back and then straighten it out. But the rest of them actually looks pretty good. That's straight enough, as I say. So then we just do the rest. Let me hit those pads real quick. There we go. Oh no. No, don't do that. Okay. Mr. Blue, I always look at the live streams at a later time, but I really like your work. Hope this helps a bit. Keep up the good work. 20 euros? Damn! Now I get a sip of my Coke. Thank you very much. That is very much appreciated, and it certainly does. Let's see. I want to hit this one. Okay. That should be all the pin headers, I think. No, I missed one. There we go. Oh yeah, I am certainly not a professional. Do not look at me like I'm a professional solderer. Even my guys that I have in China doing my production and stuff like that, they're miles better than I'll ever be. So, I mean, I can solder a board, no problem, and I do all my prototyping myself and stuff like that, but still, there's a difference. Oh no, this one still a bit crooked. I just bend it a little bit. I hope. Okay, that should be okay. Sure. As long as I can get the jumpers over there, that's fine. It's always messing with these pin headers a little bit. So let's tick off those pin headers. Because we did, let's see, which one? Yeah, we did those. No, we didn't do those. Screw terminal. Okay, this one. We don't need to do the mounting holes. Oh, we did this one. Yeah, we need a jumper, but I should have one of those. And let's see, we need to do the temp. I'm not going to do the temperature sensor. I believe that'll work, no problem. We can now do the screw terminals and then do the voltage converter and then the socket and the capacitor. Okay, so let's do the screw terminals. And in theory, those were higher than everything else we placed, so we should be able to do the same trick again. We take our pad, we put it on top, we flip it around, and then we solder one of the legs. And in this case I'll do a data channel because that doesn't need that much solder. There we go. And here I'll do the plus. Let's get plenty of solder in there. Oh, okay, that might have been a bit too much. Let me try and clean a little bit of that off. There we go, that's neater. Okay, then we can flip it around, see if it's all lined up correctly. Like, okay, let's twist it a little bit like that. Sure. This one, well, that's 4 posts, so that's likely lined up better. Also make sure it's not lifted off the board. That's also important. Looks fine. Okay, let's do the rest. So yeah, especially for these voltage and ground pins, I like to add a decent amount of solder and keep it there for a little bit, just to make sure it seeps through. There we go. I'll do the other one from the other side. Those look like neat connections. And then over here I need to do ground. Oh, I need to stay in shot. That should be fine. He wants to paste a link. Yeah, maybe you can do it on Discord and then one of the admins can paste it here if it's okay. Okay, that's looking fine. So now we can tick off the screw terminals. Tick, 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 tick. We said I don't feel like doing the temperature sensor. Where is it? Or did I already? Oh, here it is. Not going to use it in this case. Okay, so then the ESP, the voltage converter, and the capacitor are left. Let's do the converter. So we use these little plug-in DC regulators, and they have an I and an O here, as you can see, and I also have a V in and a V out on the board. So in theory it just slots here, and there should be ample space for that, like that, so I can actually stand up straight, because I tried to make sure it would fit nicely this time, since I did remove the capacitor that was over here before. Yeah, that looks good. And the I here lines up, sorry, you can see that, with the V in. Well, it's covered now. Oh, it's also on the back, so yeah. Again, what I do, I solder one of the pads. I check if it's oriented correctly, and it looks to be like me for me. And then I just solder the rest of the pads. Let's hit this one again to make sure. There we go. Yeah, I still don't know why only mods can do it. I spent a half an hour or so looking through the YouTube interface where I could change that, and the only thing you can change in regard to chat messages is if spam messages or something like that need to be held for review or not, which I have set so. It's not like they're being thrown away, so I still don't know why other people can't do an ad. It's really annoying. Yeah, exactly like Philip is saying. I've been checking that, but no clue where I could find to change that. Absolutely no clue. Okay, well, we'll probably snip these legs off in a little bit. I know you're not supposed to do that, but you know. Okay, so that voltage regulator is right there. It doesn't interfere with the screw terminal. That's good. And this one is fine too. So let's take off the voltage regulator. Let's do the ESP. Now the ESP socket changed a little bit, and I wanted to verify something, because you need a row of 9 pins and a double row of 9 pins, like that and like that. Okay, so that still fits correctly with the screw terminals, but I'm wondering if you got instead of an 18 pin, yeah, so that still works. Okay, that's good. If you got a 20 pin, for instance, which are more common, and a 10 pin, which are also more common, then you can just have some of the pins here hanging over, as you can see here, and you can just pull those out or snip those off or whatever. But then at least you're a little bit more flexible in the type of female header socket or pin socket you need, so you can still use, if you don't have an 18 and a 9, you can use a 10 and a 20, for instance. Okay, so what I'm going to do, if I can find them again, oh, here they are. I'm going to take a QuinLED ESP32, and I'm just going to put it in those pin sockets. Squish it in there. There we go. Because then I can put it back over it, and I need to make sure it's aligned correctly. All the pins are going in. There we go. Okay, and that'll add a little bit of force, so now I can just lay it on its back, because now that is the highest component, and I can easily solder those pins. Let me focus that for you. This capacitor is a little bit crooked, but it'll still work fine. So now I don't have to worry about what did I do? Orientation and if it's incorrectly or something like that, because I know it is. There we go. That was pretty easy. So let's do this side. Oh, touch the capacitor. It's still okay. Ah, okay. So I didn't pay attention well enough, and the sockets actually lifted up slightly. Damn. Not sure I'm still going to be able to fix that. Oh, it is so on the other side too. Yeah. Okay. I should have not done the voltage regulator first, because that is the highest point. I thought it wasn't. As you can see what happened, right? So this was higher than that, so this wasn't pushing in correctly. But in theory, as long as all pins make contact, which I know they did, it'll still work fine. It'll just look less pretty. But not much I can do about that now. Well, actually there is. I have a desoldering station, but most of you guys don't. So I'm just going to continue like this now. But as long as all pins make contact, that should be fine. It's also not like there's going to be a lot of amps traveling through there or something like that, so... Okay. Even the pros have this. Well, I guess I'm a pro now, because... Are you a pro because you don't have a day job anymore? Does that mean you're now a pro? I think you're just still as much pro as before, but I don't know. Okay, cool. Okay, and well, then we need the last component. Let's throw it around. And that is a capacitor. And in this case, it's going to be a 35 volt 1000 UF, because the V3 DIY version is now compatible with 24 volt LED strip. And it always has a band on the side, and that band matches up with the color, or the white in this case. There's also a little plus over here, as you can see. So it needs to go in this way. And I made the footprint a little bit different, so that you can use two types of spaced capacitors. In this case, we're going to use the middle holes, because those are fine. Well, it's a tight fit, but it fits. So for this, again, the same. Solder one of the legs, and in this case, solder the leg with the trace coming off of it, because that has the least amount of copper. And then check if it's straight and push down on the board, like I should have done with the sockets. There we go. You are a pro! Thanks, man. Thanks. And then we solder the other side. Okay. And, well, now we need to get the snips. The snips! So I use these handy dandy side cutters. If you don't have those, I really recommend you get some. They are on the equipment page. And we just snip off these legs. Come on. There we go. That's okay. And the legs of the DC-DC converter are a bit long, so I generally also snip those off. Now, watch out, because they will really try and spring away. So what I usually do is I put my finger there so they don't spring away, and then, you know, they stick to my finger, but that's fine. Okay, let me get rid of that, because I don't want it on my work surface. I hit something on the way to the waste bin. Now it's on the floor. That's fine. Yes, yeah, because if you can't get the right capacitor footprint, or especially on AliExpress, you get a different footprint and stuff like that. I thought, okay, let's use a little bit different footprint, so you can use either spacing. As long as you use the two holes or the two, sides, you're fine either way. So, okay, so now we have a QuinLED-Dig-Uno V3 DIY. Huh? Because, let me tick the last boxes. I did this. I did this. Yeah, it's all green. The backside, all green. Nice. Done. This can go away. No, not that. This can go away. Sorry. Okay. So, yeah, this slots in like normal. Well, it's standing up a little bit because I made a boo-boo. That's fine. Let me find the fuse here somewhere. Sure, 5 amp fuse. This should go in fine too. There we go. The USB socket is very close to the fuse. That's normal. It's been designed that way. But as you can see here, they're actually not touching. And these fuses are a little bit thicker than normal fuses. So that should still work perfectly fine. Yeah. They're also compatible with a generic ESP32. Of course, I like using my own version better. But you can still use the normal mini 32s, or if you'd like an Ethernet version, we take this one off, put that one on, make sure the pins are in on the back, because that's how I always verify. And now you have an Ethernet port on your DIY ESP32 with all functionality, because the pinout of the V3 is the same as the V3 pre-assembled, right? So yeah, you can use Ethernet, and in the future, as I teased before, oh well, it's still on a pre-assembled Dig-Uno. I mean, can you see the resemblance? DIY and pre-assembled next to each other. From the front, they look pretty identical. From the back, you can see there's a few more components on this side. And that's all the auto DC regulator blah 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 circuits. So yeah, but anyway, you can now put this one on here too. There we go. And then you actually get extra channels and a microphone and SD card slot and stuff like that. But yeah, that's future talk. Yes, these are full size, but you can also place the minis. That's true. And especially if you want to use the... I'm not sure you can actually use the USB-C socket if you use the mini. We could try that, I guess. I can get some minis. Hold on. I'm done soldering, so I can remove my glasses. Okay, let's see here. Oh, my hair is a mess. So this is a medium. No, these are medium size, I believe. I don't know. Hold on, let me pull this off real quick. Come on. There we go. So there's two different sizes. There is a mini and ultra mini, I guess, or micro and mini, I don't know. I believe these should fit. Yeah, because it just needs to, go in between the clamps, and that seems to make a fine connection. Yep. Oh, that's stuck in there. And you can actually, I think, also use these. Yeah, that works. Because, again, it needs to go into the clamps, and this one's definitely in there. And this one is definitely in there too. So that's fine. And then you could actually use the USB-C socket if you wanted to. Because on the QuinLED ESP32 there is a protection diode there, so you can double feed the board and nothing bad should happen. On other ESP32s, I'm not gonna warrant that basically. But if you wanted to use the USB-C port with a fuse in there, with one of these micro fuses, you can actually do that. Now I wonder if I can still get it out, but that's why I got this tool. Although I don't know how to use it. Let's see. Maybe I can pry it out. Well, it's certainly stuck in there. So that's good. I mean, if it's stuck in there, it means it's making good contact. Let me just, extract it like that. So yeah, I like these fuse sockets a lot because it gives you the option to use the big ones and the mini and the micro. I don't know how to call it, and especially because this one has the legs on the side here, it's very tiny. You're amazed at how easy it was to make. Well, thank you. In part, I think that's design. In part, I think that's video showmanship, as in, once you start doing this yourself, you might find that, bridges everywhere and solder getting stuck at the wrong places and all kinds of other crap is happening, but they're not that hard to build. They're a good DIY project to start out with. Even though there's SMD components on there. Oh, wait. Even though there's SMD components on there, in my opinion, they're very easy to do. You just need a tweezer, and the method I kept showing the whole time. You tin a pad, you push it in there with the tweezer, you release the soldering iron, you release the tweezer, you do the other pad, and you're done. So I actually like soldering SMD components just as much or more than through-hole. So yeah. And the reason they are SMD components is because the design would basically not be possible otherwise, at least not in this form factor, because a through-hole component, well, it basically says what it does. It goes through the board, so it intersects with both sides, and it'll intersect with voltage planes and stuff like that, which would lower current handling and cause all kinds of other crap. And that's why they're SMD components. Why can't the auto voltage feature be on the or on the DIY boards? Well, basically, on the pre-assembled version, it needs this. And even though this was pretty easy to build, I think my camera actually ran out of battery. I was already wondering about that because it wasn't fully charged. Let me get a new battery real quick. Yeah, let me do that. We are going on a little break. Get a drink, get something else, and as Maikos or Philip says, maybe after the break it'll be magic smoke time. But we'll see about that. I'll be right back. in theory, I'm back. Need to reorient the camera. There we go. That's it. Okay, settings seem correct. I want a bit more music for myself. Good. Okay, we're back. And we have a new battery. We don't need the soldering iron anymore. Again, T3A from Eichstun or whatever. Look it up on my equipment page. Excellent stuff. It partly makes this look so easy as it did. Okay. There we go. Everything off the desk. Okay, so let's put the pre-assembled away. Let's do a quick flash of the newest WLED. Let's put a fuse in there. Let me go. Okay. Let's connect this. Let's go to the V2. USB device not recognized. What do you mean? Is this a borked ESP? Could be. There might be some testing code on here. Hold on, I need to do my my little press the button, put in the cable, install WLED install. Yeah, I know. Install. Okay, I've worked it. Again, press the button, cable, install. Nope. Come on. I have some board LEDs some board modules lying around here. This might be one of them. Let's try it once more. Install. There we go, erasing. So I had to do the little button trick. It depends which bootloader is on there, if that works correctly or not, sometimes. I often get the issue if I'm switching from ESP home to WLED and back. There we go. So, for LEDs, I wanted to use some WS2811 Bright, because I like those a lot. I should make a video on those. And we need a 12 volt supply. So I have a supply right here. This is a 12 volt 10 amp adapter, which should be plenty for running these LEDs. So while it's flashing, I guess I could screw that in already. Let me get the cables the right way. Come on. There we go. You were explaining the DIY board and wasn't. Oh, when it does, why it doesn't have the DC-DC on there. That's right. Because basically it would involve. Oh, I didn't snip one of the legs. Jesus. It would involve too much components to still make it easy DIY-able, and I need to select a certain level you need to be able to perform to build the board, and having to do all this wait, where is it? Yeah, having to do all this, that's not DIY-able without a stencil and stuff like that. So yeah, I want to keep it more entry level than advanced level, where you need a stencil and a good soldering iron and maybe a hot air plate or a hot air gun or a hot air plate and a hot plate and stuff like that. So this, as you saw, is easily doable with an iron only. And if we added all the other stuff, you would need you would definitely need more equipment to do that. And then the entry level goes up and up and up. And well, as I was saying, I don't want to do that. So yeah, that's why certain features are only on the pre-assembled. Cool. Okay, let's put the ESP on there. Let's go back. So WLED flashed. Let's put the ESP on there like that. Check the pin lineup. That's fine, because it's 9 pin, not 10. If you have a 10 pin board, you should have one pin hanging over the front. So the back should still line up, just to make sure. Let's input the power. The power. Come on. Oh, these are terminals with a flat head. That's fine. Okay, power is in. Right, we need a jumper to select our voltage. And I don't know if you can see here, it says 5 volt over here. And it says 12 to 24 volt over here. But we do have an extra pin, this one. But that is ground, like the other one is ground, like this terminal is ground too, as you can see here, because the white's there. So we need a jumper from this left one, which says 12 to 24 volt, to the middle one. Because the middle one will determine what goes to the electronics on the board. So if you bridge it with 5 volt, you get 5 volt. But if you don't use 5 volt and put 12 volt on there, it'll fry the electronics, right? So we use the 12 to 24 volt, because we're using 12 volt in this case. It'll first run through the regulator and then go back to the board. There we go. Or it should, if I did all my schematics correctly. I guess we're here to find out. Capacitor, jumper, need a jumper. Oh, I have a box called 2-pin jumpers. Isn't that great? 2-pin jumpers. Can we select colors? No, I don't know. I should have colored jumpers somewhere. Let's just use black for now. Don't want to look for them. Okay. So we need the two leftmost left pins, and we bridge those like that. And that should make it so that it's in 12 to 24 volt mode when we turn it on. Okay. Let's collect the LED strip immediately. So we take the ESP off again. Let's take our roll. It's always good to look at the arrow on the LED strip, which way it's pointing. That's good. I'll show you an overview in a minute. Let's get a easy connection block thingy. You know, not sure if you should use these in real production scenarios, but we're using it now. And since it's 12 volt, it'll do okay. Alright, is the silkscreen readable with the bigger level shifter on there? Yeah, LED 1, LED 2. You can clearly still see that. That's good. That's good. Okay. Arjen Sterrenborg says, so if you would want to DIY the different QuinLED boards, how would you go about getting the components? Is there a certain place to get them? Oh yeah, Wowstick. What bit? This is the PH1. Can I show you? Yeah, PH1. There we go. Yeah, so Arjen, on QuinLED.info in the digitally addressable LED section, there is a section for the Dig-Uno and the Dig-Quad, where you can find hardware guides, soldering guides, and stuff like that. Now, this is the new V3 DIY. The current guides and everything are still for the older versions, but they will be updated once this is done, basically. Well, not this video. I still need to do the work, but, you know. And I have links to AliExpress article or items and stuff like that, but you can get them anywhere you'd like. Yeah. Okay. So let me move my drink. Plug this in, and let's zoom out the camera. To get this in the shot. There we go. Because in theory, this should start working pretty soon. Unless it blows up. Right? I hope not. That would be bad. Okay, are we ready? Are we going to turn on the power? We're going to turn on the power. Did I do anything wrong? You have to tell me now. Yeah, looks good. Looks good. Let me know. Did I do anything wrong, or should I turn on the power? There's 129 of you guys watching, so with me, that's 130 people. Did I do something wrong? Correct, Philip. Especially the higher power ones. This will draw 100 watt. Not the way it's injected, but yeah. Flip it! Turn on the switch! Live a little! Prepare for magic smoke! Okay, let's do it. If the stream cuts out suddenly, you know what happened. Let's do it. Oh, we even did the power LED correctly. Hey, nice. ESP turned on. So it didn't fry because it's running power through the DC-DC circuit. That's good. So let's go here. The ESP should now be back online. It is. Can we change? Oh wait, we can't change colors. We don't have any LEDs yet. Okay, configure LED preferences. It is GPIO 16 and we have 100 LEDs because it's 300 LEDs in total, 60 per meter. But since it's per 3 addressable WS2811, we have 100 LEDs. Let's turn the brightness limiter off and hit save. Oh! Wait, did I miscount? Oh no, it's not 60 LEDs a meter. It's 96 LEDs a meter. Sorry. So 96 times 5 divided by 3 is 160. We have 160 LEDs. There we go. That's better. And let's check red. Red is good. Green is good. Blue is good. Nice. And the board's not smoking. Let's see what we're drawing. 23 watts, but since we're on 12 volts, that's only 2 amps or so. Cool. So now we can do all the cool stuff. Like, you know, or, I don't know, color twinkles. Oh, look at that. Nice. Now, I like the WS2811 bright, and I'm not sure, they are in my LED strip, guys, because the colors, as you see, are very vibrant, much more so than normal LED strip, or normal adjustable LED strip. And the reason for that is, if you see this LED strip, it has these chips here, and they aren't built into the LEDs. And what that allows them to do is, instead of having the integrated chip, which then also always has the same LED, they can vary the LED packages themselves combined with the chip. So between the normal version and the bright version just uses a lot better quality LEDs because, well, the controller isn't in there, so they can select any LED package they want instead of the normal one that's an all the strip with the controller built in. So, hope that makes sense. But yeah, it's working. Oh, let's make it pink. That's right. So, let's go solid. And is this... oh, that's a bit overpowering. There we go. Is that pink enough for you, Johnny? Yeah, that's good. Let's go full power. 57 watts drawn from the socket. That's pretty good. But yeah, we can do, you know, fireworks. Pink fireworks. Nice. Or starburst. A little less brightness. So, another reason I like this strip, it's 12 volt per 3 addressable, but since it's 96 LEDs a meter, the downside of per 3 addressable kind of falls away because it's 160 zones for 5 meter, which would be the same as 5 volt 30 LEDs per meter. But since the LEDs are closer together, effects like this, for instance, no, this one, blend together better because there's more LEDs closer together. So I really like this strip. It's a little bit of a compromise, but it being 12 volt and having the better quality LEDs and them spaced this tight together, it's awesome. I'll do more videos about that in the future. I should have done those a while back, but yeah. But I guess that means the controller is doing what it should, right? We soldered it together. You saw I can do it, and that mostly means other people can do it too. My son keeps bugging me. He wants annoying LEDs while he plays Fortnite. This seems to be the way to go. Yeah, this'll do it. Yeah, Emil Bart, check out these WS2811 Brights from BTF. They have great red, blues, and greens. Much better than the generic stuff. Absolutely. No, these aren't hot yet. I'm not running them a lot. I'm running them at, let me show you. What is this? I don't know. 1/4, 1/5 of the power. So, they're not going to be running hot. That's fine. If you run them full power, they'll get hot because there is a lot of LEDs there. And basically there's about 60 watts going in. Now, a big chunk of that is becoming light, but another chunk of that is becoming heat. But yeah. This is IP65 because it has the coating on there. They are in my LED strip guide, and that, I believe, is in the description. But I can paste the link real quick. Hold on. They are a bit more expensive, of course. LED strip buying guide. WS2811 Bright. I think it's this one. Let me check. Yeah. So use this link. Ricardo, yes, especially if you're talking analog LEDs, this can actually melt the spool. For digitally addressable LEDs, it's less, they generate less heat because they're more constant current and constant voltage and resistors and stuff like that. But you're right, don't do this unless you're just testing a little bit at low powers. Oh, Johnny's adminning it again. Nice. You should flash Tasmoda on this. What? What would make Tasmoda better than WLED? There's nothing better than WLED. Come on. I mean, I don't know. Let's do this. Oh, that's a bit fast. And even though this is per 3 addressable, as you can see, it's still very defined because you have the 96 LEDs a meter. I don't know, what's a fun effect? Twinkle cat. Twinkle fox. Twinkle up. I don't know. It's all in pink. Let's go random. Yeah, not sure what else to say. I didn't really encounter too much issues while building. Component-wise and spacing-wise, I think it works fine. I need to do some work on the BOM, because I could change this capacitor we have here from 1206 to 0805. That'd be fine. And I can also change this LED we have here to 0805, because that's also 1206. I don't think it needs to be 1206. Other than that, I don't think we encountered any real issues during the build that we need to change. Yeah. That's looking pretty good. Ah, you're a Tesmoda user. Okay. Well, I like ESP-Home. You love the ESP32 form factor. Oh yeah, absolutely. It makes a nice little, neat little package like this. And the antenna sticks out for good coverage. Yeah. Of course, if you're getting a QuinLED ESP32, you can now also use the ABE variant, so with Ethernet. Or you could go for, I don't have one here, but I have one of these. The one with the external antenna connector. And then connect an external antenna for if you're mounting it in a box or you need a little bit of extra range or something like that. And that will all work with the V3 DIY like it works with the pre-assembled too. So the biggest difference there really is on the Dig-Uno is that you have to place the power jumper, and not forget, on the pre-assembled that is done automatically basically. The VEXT function is also on here. And it works a little bit different than before, but it's easier now. But yeah, that also requires a little bit of extra work instead of on the pre-assembled version. But that's just because I don't want to build those complicated circuits on there. I've got WLED, ESP Pixel Stick, Tasmoda, and ESP-Home. They all have their place. Well, amen. I'm out of a drink. How long have we been streaming? 1 hour and 49 minutes. Cool. Let's make it 2 hours. I don't think there's any difference except for the reflection at Arjen Serberg. Any comment on the PCB color of the LED strip? Oh, right. So these are white. I actually have black ones on the way, I believe, because I do want to make a comparison video. Basically, if you want the colors to blend more together, you should get white backed strip. And if you want them to look more like individual LEDs or pixels or whatever, you get black strip, because then it doesn't blend so much on the LED strip itself. And it looks more defined, basically. So, yeah. There is a A0 pin that you can use for a microphone. Or in the future, I'm bringing out this board. And this will have a digital microphone integrated into it. So if you want to go the easy route, you do that. And otherwise you get a little analog microphone from AliExpress. And you can plug it into the analog pin. And that'll also work. There's also 3.3 volt and 5 volt pins you can use to power it. And yeah, just plugging it in. And that should work fine. But that's also all in the pinout guides and stuff like that. Let's do some more effects. What's a good one? Oh, I like Pacifica. Yeah, seems to be working fine. I'll be doing some load tests later on to see, well, how well the new version handles the load. But I don't expect much difference versus the previous versions, so it'll still be rated for 15 amps and stuff, continuous and stuff like that. I did get some more clearance on some components, and there is a PTC on here now which wasn't there before, so there's a little bit extra security on there. Although the Dig-Uno already had a input fuse anyway, through which all the power was run. On the Dig-Quad, it's a slightly different setup. So, you know, an extra PTC can't hurt. It's mostly pinout and some board layout updates, Shifty. It's not like this one suddenly has magical new features or something like that. The old DIY, the reason I waited as long as I did with making a new version is because for what it was fine. And making an updated version meant doing one or more prototypes and a lot of work and stuff like that. So I'd rather do that when I had the time to do it right, like this, than botch something together and maybe, you know, F something up somewhere and people would get boards that didn't work right. And, you know, so I'm still going to do a lot of testing on this. I think it's going to be fine, but, yeah. You know. When will the Quad DIY come out? Would it have the same options as pre-assembled? No, it would have the same options as this one, but then in a quad form factor. So basically the same stuff except for the auto inputs, auto voltage, auto VEXT, stuff like that. Yeah. Yeah, like Philip says. Yep. Yeah, the mic will be on the hat, but you can always plug in an analog mic too, because the pins are broken out. So if you get an analog pin and you use some DuPont wires, you can put an analog microphone on here with 3 wires and you're done. Because the A1 pin or the A0 pin, can I find it on the back? Yeah, here it is, A0. Well, you can't see that. But A0 is broken out, so you plug in the microphone there. 5 volt, ground, and 3.3 volt are right there too. So you plug in 3 wires, done. Works. Cool. Glad you like it, Jaco. Yeah, this is basically an attempt to keep it as small as possible while having high current handling, decent screw terminals, a fused socket, capacitor, dual level shifters for 2 channels, and you can select the resistor on this yourself because you're building it yourself. Yeah, I get people use bare ESPs, but there's just a limit to where you should use those. And if you go above a few amps, yeah, this just makes it a lot easier. I hope people don't stop buying the pre-assembled, because I kind of live off of that money half a little bit now. Nah, it'll be fine. I love DIY. I'll never stop doing DIY. I mix it with pre-assembled projects. I think people can understand why. But I'll never stop building DIY stuff too. Because, you know, that's how we all got started. And that's why I love doing it. When will the release of the pre-assembled AN Penta? There is no plans for that scheduled yet. This year. I don't know. This year. Is microsd used with WLED? Currently no, but it might be in the future. What is the current shipping cost for parts to pre-assembled is a bargain? What? Oh, with the current shipping costs for parts to pre-assembled is a bargain. Yeah, worldwide shipping is totally effed. And you can also see that on AliExpress trying to get stuff. You'll pay $1 or $2 shipping also there. Yeah, it's just difficult right now. Thanks, Savog. I'm glad you like it. It went together pretty well, and you know, there's no spacing issues here. I know it's slightly tight getting a DuPont cable in here, but let me show you. You can actually just do it. That's still fine. See? Uh-oh. What did I do? Oh, somehow I reset the controller. Do I have a loose solder joint? I don't know. Did I push the button? Oh, the button still works. So you can use actually the boot button to turn WLED on and off. Don't know if you knew that. Because it's tied to GPIO 0, just like the pin is. I don't know, maybe I touched a pin somewhere. Anyway. Let me try that again. What did I do? Can't make it happen again. Yeah, so I got a lot of comments like, hey, I can't get my DuPont cable into the second row. Well, in my opinion, you can. Okay, on this side it's a little bit tighter, but that just means the DuPont cable is wedged in there. So it's nice and tight and snug, so it won't fall out. It's a feature. That's actually, when I designed it, I knew it was going to be tight, and I actually thought that'd be a good thing, because, literally, then it won't fall out that quickly. I don't know, I must have bridged some pins somewhere to make it reset like that. Huh, interesting. Anyway, DuPont still work? Static? Yeah, could be. Maybe I hit something. I'm not sure. Because, I mean... Yeah, okay, let's not drop it from too high, but I'm banging it around pretty good. The LED effects are going, so, I mean, you can see the whole cable. It's not fake. Okay, you can't see the whole cable. Well, it's right here. I don't know, maybe some static, I guess. It's on there pretty securely. Feature, not a bug. You got it. Your stream helps a lot, though. Thanks. That's why I do them. I like doing them and talking with you guys, so hey. You paid $25 shipping when ordered a couple of Dig-Unos and Quad earlier. Yeah. Shipping can be rough. I get that. And I get a lot of requests for a shop in the EU. But what people need to understand, I will then need to ship it here. So you get shipping charges, just like you have. Then, because I have to bulk import, I get import fees. And you can say, well, you're bulk shipping too. Yeah, but with the import fees combined with the bulk shipping costs, it's basically the same as you'd pay for shipping yourself. Then I have to pay for storage and handling. Either I do that myself or I pay someone to do that. And then when I sell it to you, you have to pay shipping again. So basically, whichever way, it'll be more expensive than it is buying it directly from China. Tax-wise, it's the same nowadays, because you always have to pay tax. So getting it local in the EU would maybe get it to you a week faster, but that's it, because it'll always be more expensive than buying it directly from China, even with the shipping costs. So, yeah. When is the legacy version of the ESP32 ABE coming? Those should be available, Den Bell. Probably only from worldwide, but still. If they're not, ping me on Discord, and I'll ping them to add a few in the store. Yeah, but the boot button should just turn it off and on like that. I might have hit the LDO here, and that rebooted the ESP. But yeah, the button should, turn WLED on and off. So I'm not sure what happened, but maybe I wiggled the fuse? I don't know. Seems fine now. Maybe my socket is because it's a little bit crooked? Yeah, I don't know. Making it in the EU. If you can find a shop that can make it for the same price as I do in China, that's fine. Ryan Knodel says, thanks very much. Looking forward to building the new version and the new add-ons. Cool. That's always good to hear. Oh, Jasper got his Dig-Unos after waiting for a couple of weeks. They work flawlessly. Thanks for all the stuff you do, Quinn. Happy to do so. So I can run an 8-meter strip with 96 LEDs on one channel? Sure. Because, let's count that up. 96 times 8, that's 768. That would be too much for single addressable, but we have to divide that by 3, and that's 256, so that's perfectly fine for on a single channel, because that's well below 600 LEDs like we advise. Just finished all my V2 or 6 boards, looking forward to the build V3. Yeah, I get that. Sure. I mean, If you just use them, there's not too much difference between the older and the newer ones. But if you want to use the add-ons, such as the Ethernet or the upcoming other boards and stuff like that, that's basically where the difference is. And other than that, well, there may be some slight safety improvements with the extra PTC and some extra clearance here and stuff like that. But other than that, they're mostly the same boards. So, yeah. So, LEDs, when you turn them off, I can check here. Let's see here. So, because of the power supply and the LED... Okay, currently we're drawing 7.4 watts from the socket. And if I disconnect the LEDs, we're drawing 2.7 watts from the socket. So, the LEDs alone are drawing about 5 watts on standby. Now, it's up to you to determine if 5 watts of idle current, to be able to push the button and have them turn on is too much or is okay. Oh, donation for the A and Penta. Thanks, Andalage. I appreciate that. Cool. Well, we passed the 2-hour mark already. Let's go back to the face cam. As I said, I will be doing more testing on this. I will be doing load testing and long-term load testing, like 15 amps for 3 hours, for 1 hour through the board and stuff like that. I'm actually using some new load testers I have recently gotten. They'll be in a Quinn box near you soon. But I've been using them for about 2 weeks already. I really like these. They're from AliExpress and they do really well. But as I said, they'll be in a Quinn box soon. I'll probably do a dedicated video about them too. But then again, I also have my LED load bars we constructed in earlier videos, and I do both tests. I do load testing. I have a different electronic load too. I used for that before, and I do real-world LED load testing too, because maybe the board can handle the power, but then the logic still needs to work. So hey, how much amps for one channel is possible? Well, this only has a single in and output terminal, and it has 2 data channels. So the board is rated for 15 amp continuous. So that's what you're allowed to draw through the board, basically. So that doesn't have that much to do with data channels or not. If you need to do more power injection and stuff like that, sizing up to the Dig-Quad makes it a lot easier, because that has 7 positive and negative terminals and 5 fuses and can handle 30 amps and, stuff like that. So, yeah. Be fast in your testing. I need to make them ASAP. Well, people who watch the live streams always get the scoops, but it'll be a few weeks at least before I can get all the new guides and stuff like that done, because I'm also busy with a lot of other stuff. So it'll be a little bit, but they're coming. Especially if this prototype is okay, they're certainly coming, but yeah. Add a MOSFET? What? Well, you can add a MOSFET. But then again, if you want a MOSFET that'll handle 15 amps continuous, okay-ish with decent cooling, you need to design something for that. Teaser time! Actually, I don't have a teaser right now. Sorry. So I guess the whole DIY thing is a teaser already. For what's to come, because they're not here yet. No teaser! Aww. Yeah, no, I'm sorry. I'm working on some stuff, but it's not ready yet. Had some problems with my quad getting the right size wires and the yellow plugs. Okay. What are we talking about? You mean these? You mean these new terminals? Sorry, I'm cheating on you, Quindor. What are you doing, Maiko? What? Magic smoke time? No, no magic smoke time. I guess I could, I don't know, show you how I beefed up my power supply this week. This is my UHP 500 from Meanwhile. I actually have a bigger power supply coming because for some projects I'm working on, 80 amps 5 volt isn't enough. Anyway, this is it hooked up with 2 times 10 gauge, so 6mm square cables with fork style terminals. Because I was actually testing the Dig-Quad up to 70 amps, and that worked. It worked fine. Sorry. At 70 amps, it gets a bit toasty. Parts of the board get 70 to 75 degrees. That's a bit too much, especially free air. And if you put it in an enclosure, it'll get warmer than that. But yeah, I needed some high current handling for an upcoming project. And although this one does 80 amps, I actually bought a power supply that will do 120 amps. That's just insane. But yeah, that's for future experiments. So I guess you get a little bit as a teaser too. But I really like the look of this beefy 6mm square cable with fork style connectors, and it's stupid. But it goes into a Dig-Quad perfectly now. You know, with the new style terminals that just goes in there easily. Anyway, 10 gauge, yep. Yeah, you don't want. I don't want voltage drop. No voltage drop. Oh no, I replaced the connectors on the "This is not how you should crimp a cable." These are all perfectly perfectly crimped, as you can see here and here. Yeah, it just looks so awesome. I don't know. There's something about beefy wires, I guess. I don't know. Am I the only one? What size fork terminals are those? I can look that up. Let me get my little box of fork terminals. No. Oh no. Right. Anyway, those are SV 5.5 minus 4. And I have them in black and red, both, as you can see. And I just got the, 100 pieces from AliExpress. And those work fine. I hope that helps. I'm just throwing fork terminals everywhere. Okay. The pre-assembled and the DIY boards are working flawlessly. Excellent to hear that. I like those pure copper 30mm square power bars. They're basically just giant copper bar. Don't even bother with insulation, just bare copper. Yeah, well, that's a bit too much. You just showed those yellow terminals again. What size are those? You mean these? Are these the yellow terminals, you mean? These two? They are 9.5mm spaced. And they can accept ferrules or the forks I just showed. And, well, as you can see here, these are those forks I just showed. And those fit without a problem, as you can see here. So those just go like that. And this one then goes over here. Don't know if I have them unscrewed. No. This one? Yeah, okay. I don't have them unscrewed. But these fit perfectly fine, as you can see. So then you can fit 10 gauge. 12 gauge would be a bit easier maybe, but 10 gauge fits fine. Yep. The ferrules. The yellow ferrule. Oh! Oh! Sorry about that. You mean these. Okay, hold on. They come from one of these boxes, and so the orange is 0.5, the white is 0.75, and the yellows are 1mm. So yeah, But I just get one of these boxes, and then you get all the different variants. Those are all on my equipment page, including the tool you need to crimp those and stuff like that. Yeah, you take a ferrule that matches the size of the wire. That's correct. Yes. And then because I also have the orange ones on here, because this is thinner wire than this one was. And for instance, I like using, where is it? Yeah, I like using 18 gauge for a lot of my cables, and those also fit perfectly because you really can't get it off with the 18 gauge cable. And I believe I also have 16 gauge here somewhere. Not sure. Is this a 16 gauge? Yeah. So the 16 gauge, those are thicker. So there I use a wire size higher, or a wire ferrule size higher. So these are also really on there, and they close pretty tightly. And yeah, you just use the ferrule size for the type of cable you have. So getting one of those boxes makes it easy. Oh yeah, don't use these. Because as you can see here, this is a 10 amp power supply. And you often get them with one of those barrel plugs. Now this is a 12 volt version, so it's already a little bit better. But these blocks will not do more than 3 amps, whatever the voltage is. So I just snip off, as you can see, I just snip off the connector right after this thing, the choke, and I put on the ferrules, and then I plug it in directly. Don't use those converter blocks. Those are bad. Cool, well, I'm gonna end the stream anyway. I thank you all for watching and suffering through me soldering this thing together. We did pretty good. The ESP could have gone on straighter than that, but it's okay. It's working. And the fuse can still wiggle, so that's fine. All in all, seems to be working great. So I'll do some load tests, and I'll build some Dig-Quads. Do we also want to build a Dig-Quad on stream? I guess we could do that. Not right now, but sometime. And I thank you for watching. I thank you for donating. And I hope to see you guys back in the next stream. Video, Discord, comments, whatever else. Catch you guys later. Bye-bye.
I am wandering in the deep dark blue. You left me here when our time was through. And under the covers beneath of the surface, I can't find the others who work out my purpose. I'm in the deep dark blue. I'm in the deep dark blue.